So we've been talking about momentum for the past couple of weeks, and of course we know that the momentum of an object is equal to its mass times its velocity. And we also know that momentum is a vector quantity, and so directions matter. One of the things we learned also was that the impulse is equal to the change in momentum, and impulse is basically defined as the force applied to an object over the time in which that force is applied. But I don't want to really deal with that idea right now. I'm kind of thinking instead of impulse, I want to talk about conservation of momentum, and that involves collisions. And so I have here set up behind me two collision carts and a track. In a moment, I'm going to trip a little trigger. A plunger will come out of one of the carts and it'll force the two carts apart. Each of the carts has a mass of 500 grams. And what I want you to do, given a little bit more information, is to try to figure out the speed of the carts. And my first question to you will be, will the carts have the same speed? So a follow-on question might be, will they have the same velocity? So in a moment I'm going to simply trigger the two carts apart, and let's see what happens. So your objective is to determine the speed of these carts. Ready? Oh, hold on. Let's turn on the clock. I don't know if you can even see it, but let's try it. Ready, set, go. So each cart traveled 76 centimeters. So this time we have a similar situation, except the cart on the left has more mass. I added a total of 250 grams, bringing its total mass to 750 grams. This cart has a mass of 500 grams. I'd like you to pause the video right now and see if you can predict the speed that these two carts will separate at. Okay, and now I'm going to try to launch the carts. This is trickier than it looks. And let's see if you can verify your prediction. So we have a situation now that's similar to the one we just viewed, only this time I have essentially doubled the mass of the cart on the left. So 1,000 grams, while the one on the right has 500 grams. Again, I would like you to pause the video and predict the relative speed of these two carts. And now I'm going to try to launch this. Again, this is not an easy thing to do, but let's see what I can do here. And I would like you then to verify your prediction by calculating the speeds. So in this experiment, what we're going to do is we're going to collide these two carts. I'm going to give this some initial velocity, and of course that has zero velocity. So this will have some momentum going into the collision. This one will not have an initial momentum. And both carts, they're about 750 grams each. So they are identical in mass. So what I would like you to do right now is to write a sentence or two to predict what will happen when this cart runs into that cart. I would like you to predict in a general sense what will happen, and then be more specific. Maybe calculate a predicted speed. The green dots that you see along the track here are placed every 10 centimeters to help you calculate calculate speed. So go ahead and pause the video now and make your predictions. What will happen when they collide, and then what do you predict the new speed or speeds will be?
This will be an inelastic collision.
Okay, so I'm going to go ahead and launch this, give it an initial velocity. Let's see what happens.
Here we collide two cars at the same mass and the same speed.
I'm going to try to collide these two carts together, and they both have the same mass. I'm going to try to get them the same speed, although I might not be successful. And what I want you to do is to figure out their speeds after, both before and after, and compare their momenta before and after. So let's try it.